today we are going to be looking at a problem called valid anagram. This is relatively straightforward, so let's get right into it. So the problem says that we are given two strings s and t, and our job is to return true if t is an anagram of s and false otherwise, which means t is not an anagram of s. So firstly, let's understand what is an anagram. So an anagram is basically a rearrangement of letters to form another word. So for example, if you see TAR and RAT would be anagram because both of them contain the same letters and both of them can be rearranged to form one and another. So our job here is to actually validate if two strings are anagram, and let's actually think how would we go about it when we have a pen and paper method, right? So we have two words, and the first thing that I will look is that if I have every character and that character exists in the other word. So that is the method that comes straight to our minds. So that is also a character counting method. So basically we are going to count the characters. So this is going to be pretty straightforward, right? So how we are going to do this is to actually maintain a dictionary of the letters, and we are going to run through the strings, and we keep the count of the different characters into two different dictionaries. At the end, we are going to iterate over all the characters in the dictionary and check if the count of the characters are the same. So let's go ahead and give this a try. So the first thing that we're going to check is, firstly, if two strings have different lengths, they cannot be an anagram because you can't rearrange the letters to form the other because the length is firstly different. So let's do that basic check. So if the length of s is not equals to the length of t, then we're going to return straight away false. And now if it's both the same length, then let's create two different dictionaries. So smap to is a dictionary for s and tmap for string t. What we're going to do is to iterate through the letters in s. So for ch, which is short form for character, in s, if the character is in smap, then what we do is we increment the count. If it's not in smap, then we are going to initialize the count to 1. And similarly for t as well, for character in t, if character is in tmap, then what we're going to do is to update the count, else we will initialize that to 1. So now we have two maps. They have the counts of these letters in their own strings, and now what we need to do is to check if the count matches. So if there are two different strings, so if RAAT and another string is RTAAR, we need to check if each of these letters have the same occurrence. So there's exactly one R here, there's exactly two A's here, there's exactly one T here. So these two will be anagrams. So to do that, what we're going to do is to iterate over the dictionary. So let's say for key in smap.keys, what we're going to do is to check if the key, if key is not in tmap, that means the letter doesn't even exist, or if the count doesn't match, then what we're going to do is to simply return false. And if the loop finishes without returning false, then both are definitely anagrams, so we're going to return true. So let's do a test run on the examples. Okay, great, it's accepted, and let's submit this. Alright, so this is actually accepted solution, so it is passed all the test cases. So this is one way of doing this. Let's take a look at the second way. And the second way is really going to be super straightforward, especially when implementing in Python. So let's delete everything. So Another way that we can check is to actually sort the two strings. So taking a look at a simple example, so rat and tar, if we are able to sort this, it will become A, R and T. So once we sort this, all we need to do is to actually check if the sequence of these two matches. So let's try and implement that method. So this is using sorting. So of course we will start the base case with the length check. So if the length are not equal, then we can simply return false. And now let's actually try and sort the two different strings. So before we sort, we need to actually convert the two strings into a list. So to do that, I'm going to call it a S array, and I'm going to do a list conversion of the string, right? And similarly for T as well. So we'll convert that into an array. And now let's do a sort. And same for T array. So in Python we can just simply check if these two are equal. So we can just say if S array equals to T array, this should be a double equal, and then we can return true, else we return false. So let's try running this code. Let's get this accepted for the example, and let's submit this. Again, this is also accepted for all the test cases. So those are the two methods you can use to solve for this anagram problem. So now that we are done, let's actually make a quick analysis of the time complexity. So we are converting this into a list, so this is going to take an ON time complexity, and similarly for this step we are converting a list, and a sorting algorithm in Python uses a modified tim sort, so that's going to take n log n. So here we have another n log n, and we are doing a comparison which has to go through the entire array, so this would be again ON. So based on this, we can see that the time complexity would actually be amounting to a overall complexity of n log n, which will dominate the other components. So the entire time complexity will be n log n, and we have a space complexity of ON because we have to actually create two different lists to store these elements. And in our previous example of counting characters, we had just two different dictionaries, so that will be ON space complexity, and we will have to iterate over the characters, so that would again take a ON time complexity. So our initial method has a time complexity of ON and also a space complexity of ON. And also just a quick note is that in this description we have already been told that all of the characters are lowercase. In the event that this input has a mix of alphabetical characters in both uppercase and lowercase, be sure to actually convert them to lowercase. So this is one method that you can use. Another method is that you can actually use the sorted function in Python to convert the string into a sorted string. So you can use this as well. So if you were to use that, then this will be actually looking at sorted as sorted of T, and you can remove these two steps. So this would actually also run. This is accepted, and we can submit this as well. So yes, this actually works, and it's actually faster than 90% of the submission. So this is also another possibility, but of course in this case we would still prefer the initial solution of counting the characters. Alright, find the solution on writefrombasics.com. You can come here and go into the coding sections, and you can go into the coding questions, and you can go under the strings section and first check anagram problem. So all the description is here, so be sure to take a look at that as well. So I hope this quick video was really useful for you, and if it was, be sure to like and subscribe. I'll catch you guys in the next video.